Welcome to this YSL tutorial on using basic variables in Excel VBA. What we're going to cover in this video are all the basic techniques you'll need to use variables in VBA. We'll start with a basic explanation of what variables are, and then jump straight into using something called non-declared variables, which are the easiest way to get started with using variables in VBA. Once we've covered that, we'll move on and talk to you about something called explicitly declared variables, which require a little bit more effort but are well worth it. We'll move on then and talk to you about different data types you can use when working with variables and how you can make the best decision about which data type you should be using. We'll explain a couple of the errors you're likely to see when working with variables in VBA, and the final part of the video we'll talk about something called the scope of variables, but we'll save the explanation of that for when we get to that point in the video. Plenty to do, so let's get started. In VBA, a variable is simply a space in memory that can hold some information while your program's running. To demonstrate how they work, we're going to write a really simple example, which allows us to add a new film to the end of our current list, and then displays a message telling us which film was added. So to get started, let's head back into the Visual Basic editor, and I can do that using the VB button on the Developer tab of the ribbon, or press Alt and F11 on my keyboard. And I've actually already started writing the basic subroutine that will do this. So we've gone to the correct worksheet, and then we've essentially selected the next blank cell at the end of column B. If you've watched our video on ranges and selecting cells, hopefully all the elements of this instruction will make sense. What I'd like to do now is populate the cell that I've ended up in with the name of my new film. So I'm going to refer to the active cell. I'm going to set its value to be equal to, let's see, gravity, which I keep on meaning to get around to watching but haven't quite managed yet. So that will populate the cell with the name of the film. Then what I'd like to do is display a message telling me which film has just been added. So you may not, we haven't covered this before in videos actually, but I'm going to show you how to use a basic message box. So the word MSG box, and remember you can press Control and Space on the keyboard to display this IntelliSense list. And then the prompt for my message will be gravity was added to the list. Simple as that. So if we run this routine just to test it, we can hit the run button or press F5 on the keyboard. We should see that it works fairly sensibly. We get the new film added to the end of the list and a little message telling us that that film was added. If I hit OK, that will end the subroutine. But what if I wanted then to change the name of the film that I've just added? At this point, if I wanted to add a different film, let's say American Hustle, for instance, I've got two different places in which I need to change that information, and that can get a little bit annoying. So what I'd really like to do is, rather than having to change this twice, I'd like to store the name of the film that I'm going to add to the list at the beginning of the subroutine, and then simply refer back to that value later on. And to do that, I'm going to need to use a variable. In order to start using a variable, essentially all you have to do is decide what you want to call it. So my variable is going to contain the name of the new film I'd like to add. So I'm going to call my variable new film name. It's relatively short, descriptive, and hopefully is obvious to the user what information is going to be stored inside it. To create the variable, what I'm going to do is head up to the top of my subroutine and add a new line which begins with the name of my variable, new film name. Now, variable names can't contain spaces, so make sure you avoid doing that. What I can then do is store a piece of information inside that variable. So to set the value of a variable or assign a value to it, you make the variable equal to, and then I'm going to store the literal string American Hustle. What I can do now is, later on in the subroutine, rather than adding the same explicit string, I can remove that reference and simply refer this line of code to whatever information is stored in the new film name variable. So if I type that out again, new film name, and I need to do something similar to the message box line. This is a little bit more complex. If I remove American Hustle from the existing message, because I still want to be able to see the words was added to the list, what I'd like to do is add the phrase was added to the list to the end of the new film name. So we're going to cover this in a bit more detail in a video on message boxes and input boxes, but for now I'll show you the basic technique for concatenation, which is where you join bits of text together. You can do that using the ampersand symbol, which is usually Shift and the number 7 on your keyboard. So the entire message will be comprised of the new film name and the phrase was added to the list. Okay, so there's the basics. We've created a variable and assigned a value to it, and then we've referred back to the value stored in the variable at two other places in our subroutine. I'm going to step through this routine now using the F8 key, just so you can see a couple of useful techniques when you're using variables. If I begin the subroutine by pressing F8 once, you can hover the mouse over the name of your variable and it tells you what's contained in the variable at any stage. So to begin with, the variable is empty, hopefully as you'd expect. As I continue to press F8 when I execute this line, subsequently it tells me that new film name contains the phrase American Hustle. So I can continue stepping through using the F8 key, and this would be more helpful I suppose if you could actually see what was going on in the background. There we go, so we've got to the correct cell, and then the value of the new cell will be set to be whatever is stored in the new film name variable, and there it is. The final step is to display the message, which also reads in the name of the variable. Again, there it is. And then one final F8 to end the subroutine. So there's probably the most basic way to use variables in VBA. One big improvement we could make to our system as it stands is, rather than always explicitly stating which film name we should add to the list, we could actually replace that so that we ask the user which film they wanted to add. And we can do that using something called an input box. We saw basic message boxes earlier on which display information on screen. An input box is similar, but it allows the user the opportunity to type something in as well. So to set the value of our variable using an input box, I'm going to replace this explicit string of text with a reference to the input box function, and you can see this in the IntelliSense list. Now, an input box usually needs an instruction or a question which informs the user what to do. So I can add one of those by opening a set of parentheses and a set of double quotes, and then provide the prompt to my user. I'll tell them to type in a new film name. Close the double quotes and close the parentheses, and that will display the input box on screen. So if I use the F8 key to begin stepping through, we can see that the new film name variable is currently empty, but if I step through that line, we'll see the input box appears on screen containing my instruction. Let's see, what new film could I add? 12 Years a Slave, that's getting some pretty good press at the moment. 12 Years a Slave. And if I click OK, at this point you can see that that value has now been stored in our variable. So continuing to step through, the same thing will happen as last time. We'll get to the end of column B in the next blank cell, pass the value of our film into that blank cell, and then display the message telling us that that film has been added. So that's how input boxes work in a basic fashion, and we'll have a much longer video which explains how those work along with message boxes at a later stage. So far we've created variables, essentially by making up a new word, typing it into our code, and then assigning a value directly to it. And it's nice and simple to use variables that way, but it can leave you open to some potential sources of bugs that can be quite tricky to track down. So to try to demonstrate what I mean by that, I'm going to accidentally, deliberately, misspell one of the times I refer to my variable. So instead of new film name, it's now called new flim name. I can then try to execute my subroutine, and to begin with, everything appears to work normally. I can type in a new film name. Let's see, The Railway Man, supposedly quite good. And if I click OK, I'll end up with a message telling me that The Railway Man was added to the list. However, you can clearly see in the background in Excel that that film has not been added to the next blank cell. So what's actually going on there? If I click OK, I think the easiest way to see what's going on is to show you another useful tool for when you're stepping through a subroutine containing variables. If you head to the View menu in the Visual Basic Editor, there's an option called the Locals window. And what the Locals window does is it shows you what the values of any variables are while you're stepping through a subroutine. So it will be empty while you're not stepping through a routine, but as soon as you press F8 to begin a subroutine, the Locals window will appear to show you a list of all of the variables that belong to it. You can see their values, so currently both empty, and you can also see something called their type, which we're going to get back to shortly. You can probably see here already that I've got two variables listed, new film name and new flim name. And as I begin to step through my subroutine using the F8 key to step through, type in a new film name, I'll go for the same one again, The Railway Man. I should have picked a shorter one, shouldn't I? Easier to type. The railway man. When I click OK or hit enter, when I come back to my subroutine and look in the locals window, it shows me that the value of that variable is set to the railway man. As I continue pressing F8 to step through, when I reach the active cell.value line, which is going to refer to the new film name variable, we can clearly see that that variable is still empty. So even a slight typo generates a completely new variable, a completely new space in memory, which holds a different value to the other one. So when I press F8, it essentially puts the contents of an empty variable into my cell. However, the third line, or the third reference to the variable, reads the railway man because that's what was set earlier on. Hence we see the correct message. So how can we avoid running into problems like that with misspelled variable names? The solution to our problem here is to use a type of variable referred to as an explicitly declared variable. And that's simply a variable where you're required to tell your program you're going to use it before you assign a value to it. The type of variable that we've used so far is something called a non-declared variable, and that type of variable is where you just make up a new word and immediately assign a value to it. I guess you can think of the difference as the different ways you could get a hotel room. An explicitly declared variable would be like phoning up in advance or booking online and choosing what type of room you want, whereas a non-declared variable would be you just turning up on the day and asking for a room. So to use explicitly declared variables, you have to add an extra little bit of code to the very top of your module. So if I give myself a couple of blank lines above my subroutine, I need to type in two different words: option, explicit. If I move the cursor to a new line or hit enter, I'll see that I get a horizontal line separating out that directive from the rest of my code. And what that means at this point is that I can't use any subroutine that contains non-declared variables within this module. You'll see if I try to run my subroutine, the first thing that happens is it has a problem with my non-declared variable called new film name. It says my variable has not been defined. So if I click OK, stop running my subroutine, what I need to do is declare my new film name variable before I can assign a value to it. To declare a variable, we need to add a new line of code to the top of our subroutine. By convention, you declare all your variables before you write any other instructions. To begin declaring, you write the word dim, which is short for the word dimension, although that's probably the least important thing you need to know about variables. And then you need to think of a sensible name for your variable, which actually we've already decided on. We're going to call our variable new film name. What you can then do optionally, although I would recommend doing this, it is worthwhile doing, is to say what type of data you want to be allowed to store in this variable. So you can restrict your variable to only containing certain kinds of information. To do that, what we need to do is type in the word as, and then pick from what's a rather long list actually. We're only going to use a limited set of the options in this list, and the one we're going to choose is the option called string. So string is anything which contains any kind of text. So there we go, there's a declaration for our variable called new film name. If I just respell my variable name correctly later on, and in fact there's a much easier way to make sure you never get your variable names wrong from this point on. In fact, if I delete it completely, if you declare variables like this, you'll find that they get added to the IntelliSense list. If I press Ctrl and space and start looking for the word new film name, it becomes a new entry within the IntelliSense. So that's one big major advantage of having declared variables. Okay, so let's step through the subroutine using F8, and we can see that again the locals window shows me the name of the new variable, and it's a slightly different piece of information in the value column. Previously it said the word empty there. Now it has a pair of double quotes, so what's referred to as an empty string. It also tells us that the data type itself is a string. As I continue stepping through, we'll find that everything else works normally, basically from this point on. So I can enter the railway man, and that's added to the variable, and continuing to press F8 to step all the way through, I'll eventually end up with a message, and indeed it tells me the truth this time. The railway man was added to the list. The really big advantage of using explicitly declared variables, and in fact the reason we were going to do this in the first place, is to help us pick out little bugs resulting from misspelled variable names. Now if you're using the IntelliSense list like we've just discussed, then that shouldn't be an issue, but it is still possible to get things wrong. So let's watch what happens now if I've misspelt my variable. As soon as I try to run my subroutine, I get a warning message. It tells me that I've got a variable that has not been defined or declared. And not only that, but in the background of my code it also picks out and highlights exactly where the misspelled variable name is. And trust me, that's such a lifesaver. If you've ever spent hours picking through code to find a misspelled variable name that's causing your program not to work properly, this is absolutely brilliant. So, explicitly declared variables are a good thing. I'm going to show you now just very quickly, when I respell my variable name correctly so that things will work again, how you can ensure that option explicit always appears at the top of each new module that you create. So I genuinely think it should be essential in all the code that you write. If you head to the Tools menu in the Visual Basic Editor and choose Options, on the dialog box which appears, the second checkbox on the first page of Editor, the second checkbox says Require Variable Declaration. So if I check that box and then click OK, what that means is any new module that I insert into a project now is going to automatically have option explicit listed at the top. And trust me, that's a good thing. Now that we've seen the basics of how variables work, it wouldn't be too much trouble to extend our program to allow us to include more details the next time we add a new film. So if I just quickly switch back into Excel so that you can see I've deleted the film names that we added previously. The next time I add a new film, I'd also like to include not just its name, but its release date and its length in minutes. So in order to do that, I need to declare a couple of new variables, and I need to understand a little bit more about the variable data types. So far we've only used the data type called string, and what that allows me to do is store text. But now I need to be able to store a date and some kind of number. So the best way to find out about variable data types is to use the help system built into the Visual Basic Editor. You can either click on the Help button on the toolbar or press the F1 key on your keyboard, or of course head to the Help menu and choose the VBA Help option. When the system opens, you can search for data type, and then hitting Enter should return an article that summarises the data types in VBA. It's quite a technical article, but basically all it does is list out the various data types and their names in the first column, how much memory they require to store their values, and finally a technical description of the range of values that you're allowed to store within them. So let's start with the easy one. I want to store the release date of the film, and there is a data type here called date, and the range of dates that it allows me to store is more than sufficient for what I want to include. So that's the data type I'll use for the release date of the film. When it comes to the length in minutes, that's a little bit more tricky, because most of the data types in VBA are to do with some kind of number. They range from the very basic byte, which allows you to store only whole numbers, with a quite small maximum limit of 255. Then they go through integer, long, the wonderfully named long, and then through into the decimal values, so single, double, and currency. Oh, and also decimal as well, of course. The idea behind the various different types of numbers is that what you ideally want to do is use the data type with the minimum storage size or memory footprint to hold the values you want. I think byte might be pushing things a little bit because the maximum size of byte can only hold up to a number up to 255. So what I'm going to do instead is use the data type called integer, whose maximum is far in excess of what I actually need, but it means that I won't run into problems if I do exceed the maximum of byte. So we're going to use date for the release date and integer for the length in minutes. I'll close the help system down and then just head back to our code. So now we can declare a couple of new variables to hold the new values that we want. So I can say dim and then let's say film date, for want of a better name. And the data type of this one, as we saw, was going to be as date. The next one will be dim, let's call this film length, and we'll store this one as an integer. So those are the two new variables declared. What I want to do now is provide a way for my user to give that piece of information to the program. So we're going to use a couple of new input boxes. So just after the first one, once again, I'm going to use the IntelliSense list so that I can find my film date variable. I'm going to make that equal to Inputbox, open parentheses, and type in the release date. Then on the next line, again, I'm going to use the IntelliSense list to find my film length variable and make that equal to another input box, which will ask me to type in the length in minutes. If I could spell length, that would help. So there we are. Those are the variables being populated. The last step would be to make sure that the values of those variables get transferred into the appropriate cells. So a little further down here where we pass the film's name into the active cell, what I want to do then is say active cell dot offset 0,1 dot value equals film date. And if I use my IntelliSense list to help me type it in and make sure I don't spell it incorrectly. So that will populate the column 1 to the right of the film name. And then a quick cheat here, I think. Well, it's not really cheating if it speeds up writing code in my book. The column 2 cells to the right will be the film length. So there we are. If I wanted to step through this subroutine just so that you can see that the locals window now gets populated with more than one variable. If I use the F8 key, you can see new film name, film date, film length. It's worthwhile noting that different data types provide you with different default values for your variables. So you can see that numerical data types have a default value of 0, the film date has a default time of 0 effectively, and as I pass through the program using F8 to step through, let's see, I'll go with gravity again. Capital G please. And we see that gravity gets stored in the new film name variable as earlier. When I go to the release date of gravity in the UK was the 8th of November 2013. So let's enter that. We can see that value gets stored. And then one more, length in minutes was 90 minutes. Okay, so the rest of the subroutine will just work as normal now. The values will get passed into the appropriate cells. In fact, if I just quickly show you this in the background, that's probably not that exciting. You probably work out what's going to happen already anyway. So gravity goes into that cell, the film date will go in next door, and finally the release date will go in the final column. We'll still get our message telling me that gravity was added to the list, and that's the end of the subroutine. So that's how easy it is to extend and use more variables in a program. You can declare pretty much as many variables as you need to store all the values that you're interested in. One thing you have to be quite careful of when you've declared variables with specific data types is to make sure that only the correct type of data gets stored in them. So for instance, we've got a variable here which can only accept a date, and if I try to pass in something which isn't a date, we're going to receive some kind of error. Let me show you the sort of thing you're likely to see. If I run the subroutine to enter a new film, any old thing will do just for the purposes of this demonstration. If I then try to enter a release date which isn't a valid date, let's say something like the 31st of Feb 2013, as soon as I hit OK, I'm going to receive my error message. It's a runtime error, so an error that occurs while your program is running, hopefully, obviously. And the type of problem is something called a type mismatch or a data type mismatch. And you will receive that sort of error when the type of information you've tried to store in a particular variable is not of the correct type. If I hit the debug button, it will tell me the line or show me the line which has caused the error to occur. That should be hopefully fairly obvious. It's the one where I've tried to store an invalid date into a variable which can only contain a date. So that's a fairly common error you're likely to see with specifically typed variables. Another common error you're likely to see when using data types with variables is where you exceed the limit of a numerical data type. So as you saw earlier on, an integer data type can hold a maximum value of 32,767. And if we try to exceed that value, then we're going to see some other kind of error. So if I run my subroutine again, let's put the Hobbit in, and we'll enter a valid release date this time, which was in the UK at least. It was the 13th of December 2012. And I'm going to enter a really long running time. Anything that's longer than 32,767 will cause this error to occur. Now, I know obviously the Hobbit didn't take that long to run, although it kind of felt like it at various points. But if I click the OK button now, we're going to see another type of runtime error. This time it's an overflow error. And you'll see that whenever you exceed the limits of a numerical data type. Again, if I click the debug button, that will show us that it's this line which has caused the failure in this place. And yeah, again, that's another error that you have to watch out for with variables with different data types. So far in this video, we've populated all of our variables by using input boxes, but that's by no means the only way that you can populate a variable. We're going to add one more bit of information to our film list, but the one piece of data we haven't added when we've included new films is the ID number of the new film. So I'm going to remove the details of any additional films I've added again, and the next time we add a new film, it's going to fill in all the current data, but also work out what the new ID number is. And we're going to use a variable to perform that basic calculation. So back into the Visual Basic editor, I'm going to declare a new variable. And I'm going to do that somewhere towards the top of my subroutine. So I'm going to say dim new ID, or let's call it film ID actually. Film ID as, and again, because this is going to be some kind of number, I'm going to use, let's say integer. I'm pretty certain I'm not going to get around to adding over 32,000 films to this list. So film ID is integer, and then I need to set its value somewhere. The place that I'm going to do that is just after I've reached the end of column B. So once I've got to that position, I'm going to store the film ID, or the new film ID, by making it equal to, by making it equal to the active cell dot offset -1 row down, so 1 row up, comma -1 column to the right, so 1 column to the left, dot value. So essentially at that point, if I just quickly switch back into Excel, we'll have reached this cell, and I want to store the value from the cell that is 1 row above and 1 column to the left. So it'll retrieve that number and store it in my variable. Now of course, that's not the actual new film ID. What I need to do next is add 1 to increment the value of the film ID variable to generate my new film ID. So on the next row, I can say film ID equals film ID plus 1. So you make it equal to itself plus 1. And this sort of basic arithmetic is very common when you're using variables. We need to add another line then, of course, to actually pass that value into a cell. So why don't we do it here? Active cell dot offset 0, -1 dot value equals film ID. So it places the value of the film ID variable into the column that is 1 cell to the left. Okay, so if we use the F8 key to step through that subroutine again, one more time, let's see, F8, and we'll be asked to provide a new film name, so let's put in The Hobbit, and the film date, if I press F8 again, that was, what did I say, the 13th of December 2012, and the film length, it wasn't quite 32,000 minutes, was it? It was 169 minutes, long enough. Then, subsequently, we can see clearly that all those the variables that we've populated explicitly hold their current values, but the film ID is still set to 0 at this point. As we step through, we've reached the end of column B, we're in the new cell, and at this point we're going to retrieve the value of the last film ID. Then this line will increment that value by 1, and again you can see that happen in the locals window, and then all the values simply get placed into the appropriate cells. We can actually watch that happen as we step through. The final message box appears, click OK, and that's the end of the subroutine. So that was just one quick, simple way to show you that not all variables have to be populated explicitly using input boxes. You can retrieve values from other parts of your spreadsheet to populate variables, and you can also then manipulate them with basic arithmetic or more complex calculations as well. The next thing we're going to talk about is something called variable scope, and the scope of a variable determines where you're allowed to refer to it. So at this point we've got a single subroutine which contains all of our variable declarations, and we only refer to those variables within the subroutine in which they're declared. Now as the subroutine is getting a little bit long, what if we wanted to separate it into two different parts? One subroutine which allowed us to populate the variable values, so get our user's input, and the second subroutine would then take that input and place it into the correct position on the spreadsheet. So I'm just going to close down the locals window before I do this to give myself a bit more space. What I'd like to do is end the first subroutine at this point here. So just after I've asked my user for all of their inputs. In fact, I'm going to change the name of that subroutine so that it's called getUserInput. And I should have a capital G there as well. There we go. So getUserInput. The next subroutine will begin when I want to actually find the correct position on the spreadsheet and populate the relevant cells. So I'm going to create a new subroutine here, or start a new subroutine, and I'm going to call that one add film to list. Must make sure I've got end sub at the end there again. So I've got two completely separate subroutines now, one which contains the variables which are declared and populated, and the second one which then reads those values into the correct position on the spreadsheet. The last thing I need to do is tie these two subroutines together, and I think the easiest way to do that is once I've reached the end of getting the user's input, what I'm going to do is write a line which calls the add film to list subroutine. This is a useful little technique that allows you to run more than one subroutine at once, essentially. Once the first subroutine has got to this stage, this line will immediately begin the add film to list subroutine. When it reaches the end of that subroutine, control returns to the original calling subroutine. The word call is actually optional there. You can get away without having the word call, but I always like to have it in because it reminds me that I'm calling a subroutine that I've written rather than just referring to something that already exists in VBA. Okay, so if I now begin to try running my getUserInput subroutine, I'll get to the stage where I can type in a new film name. What should we have? Should we have American Hustle again? And then I can click OK. I can't remember the release date of this one. Let's just make something up. Let's say it was the 12th of December 2013, for instance. And I've no idea how long it lasts. I'm going to say 120 minutes. Okay, so that takes me to the end. This is the last thing that will happen in the getUserInput subroutine. When I click OK at that point, I get an error message, and we've seen this one before, variable not defined. And the point at which my program's failed, you can see it's highlighted in the background of my code, is something that's in the add film to list subroutine. The add film to list subroutine has no idea what film ID actually is. It thinks it's a non-declared variable. And the reason for that is because the variable is declared in a different subroutine. Any variables that you declare within a subroutine can only be used within that one. So how do we solve this problem if we want to separate out a slightly longer routine but still be able to refer to the same variables? What we need to do to solve this problem is to extend the scope of our variables. Currently their scope is simply the subroutine in which they're declared, and we need to extend that scope to at least the level of the module. To do that, what we can simply do is cut the variable declarations from the subroutine, like so, and then paste them in at the top of the module. Just make sure that my indenting is consistent. So once you declare variables at the top of a module like so, any subroutine within that module can refer to their values. It makes it a little bit more difficult to use the locals window, the one that I closed down just earlier on. If I head back to the view menu and use locals window, if I begin to start stepping through this subroutine, you can see that I don't see any local variables listed, and that's because the variables aren't local anymore. Their scope is the level of the entire module. But the great news is that this system will actually work now. So if I continue using F8 to step through, and I can, let's see, I forgot what I'd added in before. It was American Hustle again, wasn't it? So American Hustle, and then a film date, which I think I said was the 12th of December 2013. I'm not sure that's absolutely right. And then again, I can refer to, let's say, just 120 minutes for the sake of argument. When I call my add film to list subroutine now, I don't get the error that I saw earlier on. This subroutine will simply carry on exactly as it was intended to. American Hustle was added to the list, and you can clearly see that that's true. So that's how to extend the scope of a variable to the level of a module. There is one further scope, or one further extension you can make to the scope of a variable as well. If you wanted to refer to a variable across different modules in the same project, rather than using the word dim to declare your variable, you'd replace the word dim with the word public or global. Global's a bit more old-fashioned, but it kind of does the same job as public. Public's just the preferred modern equivalent. So if you replace the word dim with the word public, then any subroutine in any module in this entire project can refer to those variables. It's a common thing to do if you're going to use public variables in your projects. It's common to have a separate module altogether in which you declare all of your public variables. But we don't technically need that in this case. We simply need variables which are scoped to the module. The final thing we're going to cover in this video is related to the idea of variable scope, and specifically what happens to the value of variables once a subroutine is ended. Now, we saw a couple of times earlier on when we had locally declared variables, i.e. ones which were declared within a subroutine. Each time we began a subroutine again, the variables were reset to their default values. So strings were set to an empty string, dates were set to a time of 0, and numbers also had the value of 0 stored in them. But that's not true when you're using public level or module level variables. I'm going to run this pair of subroutines together quickly to add a new film to the list, and I'm going to add gravity back in there. The release date was the 8th of November 2013, and the running time was 90 minutes. So gravity was added to the list, and that's the end of those two subroutines, so nothing is currently running. Now if I begin running this subroutine again using the F8 key to step through, previously if we'd been using locally declared variables, these three would have their default values again. However, because these are public variables, you can see that they retain their values from the last time they were used. So that's one thing to be very careful of, or certainly be aware of at least. When you're using public level or module level variables, they always retain their values, even after the end of a subroutine. The only way to essentially reset those variables is either to do it explicitly with a line of code. We could say new film name equals an empty string, or you can close down the workbook and reopen it, and the variables will lose their value at that point. Okay, that's the end of our video on basic data type variables in Excel VBA. Hopefully you found it useful. Thanks for watching. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.